integral 0 to n step x dx. Here the square brackets denotes greatest integer function, and we know that 0 to n step x dx is n into n minus 1 upon 2. So given here value is 66. So n into n minus 1 upon 2 is 66. So we can write n into n minus 1 is equal to 66 into 2, that is n into n minus 1 is equal to 132. So n into n minus 1, we can write 132 as 12 into 11. 12 11s are 132, so we can write n into n minus 1. So comparing, n is equal to 12 and n minus 1 will be 11. So we can write n is equal to 12. So we can go with an option C. Integral x plus sin x upon 1 plus cos x dx. So let us simplify. Sin x we can write 2 sin x by 2 into cos x by 2 divided by 1 plus cos theta is 2 cos square x by 2 dx. And this can be simplified. X upon 2 cos square x by 2 plus 2 sin x by 2 into cos x by 2 upon 2 cos square x by 2. So we can write 1 upon 2 times integration x into secant square x by 2 dx, and here we can write sin upon cos is tan x by 2 into cos x by 2 get cancelled. So 1 by 2 times, and let us apply here by parts. So let us consider this is integration of secant square is known. So let us consider this is a second function and this is a first function. And we know integration of by parts fg is equal to f into integral of g minus integration of f dash into integration of g. So here we can write x into integration of secant square is tan x by 2 upon 1 by 2 coefficient of x minus integration of differentiation of x is 1 into integration of secant square x by 2 is again tan x by 2 divided by 1 by 2 dx plus again integration tan x by 2 dx. Upon simplifying, so 1 by 2 we can take it inside, so we can get x into tan x by 2 minus 1 by 2 1 by 2 gets cancelled again here minus integration tan x by 2 dx and again plus integration tan x by 2 dx. So we may cancel these both and we can add here plus c integral constant. So we can add x into tan x upon 2 plus c will be the answer, which is option B. Option B is the answer. Integral 0 to infinity dx upon 1 plus e power x. So let us simplify 0 to infinity. Let us multiply and divide with e power negative x. On simplifying, you will be getting 0 to infinity e to the power minus x dx upon e to the power minus x plus 1. Let us substitute. Put e to the power minus x plus 1 is equal to t. So we get minus e to the power of minus x dx is equal to dt. So we can write here integral 0 to infinity minus e to minus dt upon e to the power minus x plus 1 is t. And here we need to change the limits. when x is equal to 0, so we can write t is equal to 1 plus e to the power 0, which is equal to 1 plus 1 is 2, and when x is equal to infinity, t is equal to 1 plus e to the power of minus infinity, that is 1 upon e power infinity, is 1 upon infinity will be 0, which is equal to 1. So the integral limits will change from 2 to 1 minus dt upon t, or we can change the limits by substituting minus. So minus of minus plus integral 1 to 2 dt upon t, that is log t over the limits 1 to 2. So we can write log 2 minus log 1. Log 1 value is 0, so we can write log 2 is the answer. The base is e. So we can go with an option B. Given that integral I1 is equal to integral 0 to 1 2 to the power x square dx, and I2 is equal to integral 0 to 1 2 to the power x power 3 dx. So from this both we can say for x belongs to 0 to 1, x square is greater than x to the power of 3. Similarly, 2 to the power of x square must be greater than 2 to the power of x power 3. So in the interval 0 to 1, so we can write 0 to 1, 2 power x square is greater than integral 0 to 1, 2 to the power x power 3. So which is I1, we can write I1 is greater than I2. And now I3 is given integral 1 to 2, 2 to the power x square dx, and I4 is equal to integral 1 to 2, 2 to the power of x power 3 dx. And here we can mention that for x lies between, or for x belongs to 1 to 2, we can say that x square will be smaller than x power 3. When it is a fraction, x power 2 will be greater than x power 3, but in the case of 1 to 2, above 1, x square must be smaller than x power 3. So since exponential function 2 power x square is an increasing function, so we can write 2 to the power of x square is less than 2 to the power x power 3, or in the limits 1 to 2, integration of 2 power x square is smaller than integral 1 to 2 2 power x power 3. So 2 power x square integration is I3. So we can write I3 is smaller than I4. So I1 is greater than I2. So first option it is wrong. And second option I1 is greater than I2. We can go with an option 2. And I3 is less than I4. So option D also false. And I3 cannot be equal to I4. So option C also false. So we can go with an option B. I1 is greater than I2. Integral 1 upon sin x dx. So let us multiply and divide with 1 plus sin x. So we can write integral 1 plus sin x upon 1 plus sin x into 1 minus sin x is 1 minus sin square x dx, which is equal to 1 plus sin x upon cos square x dx, which is equal to 1 upon cos square is secant square x plus sin x upon cos x is tan x into 1 upon cos x is secant x. So we can write integral secant square x dx plus integration of secant x into tan x dx. Integration of secant square x is tan x, and integration of secant x tan x is secant x plus c. So we can go with an option secant x plus tan x plus c, which is option D. integral a to infinity 1 upon a square plus x square whole power 3 dx. Let us solve this problem by substitution method. Put x is equal to a tan theta. So by differentiating we'll get dx is equal to a. Differentiation of tan theta is secant square theta d theta. So we can write integral and even we can change the limits. When x is equal to a, we can write tan theta is equal to 1. So theta is equal to pi by 4. And when x is equal to infinity, we can write tan theta is equal to infinity. So we can go with theta is equal to pi by 2. So we can change the limits from pi by 4 to pi by 2. Dx is a into secant square theta d theta upon a square plus, and here x is nothing but a square, so a square tan square theta whole to the power of 3. That is integral pi by 4 to pi by 2 a into secant square theta upon a square whole cube taken common, that is a power 6 common. So 1 plus tan square is secant square theta whole power 3, that is secant power 6 theta d theta. So on simplification 1 upon a power 5 integral pi by 4 to pi by 2, and here we will get 1 upon cos secant power 4, that is cos to the power of 4 theta. And we know that cos square theta is equal to 1 plus cos 2 theta upon 2, or cos power 4 theta is equal to 1 plus cos 2 theta upon 2 whole square, that is 1 plus cos square 2 theta plus 2 times of cos 2 theta divided by 4, or else we can also simplify here 1 plus cos square 2 theta, we can write cos square theta is equal to 1 plus cos 2 times of 2 theta, that is cos 4 theta divided by 2 plus 2 cos 2 theta the whole divided by 4. So here we can write 1 upon 4 plus 1 upon 8 times of 1 plus cos 4 theta plus 1 upon 2 times cos 2 theta. So this is cos power 4 theta. So integral, so we can write integral pi by 4 to pi by 2, or 1 upon a power 5 into cos power 4 theta is equal to d theta is equal to 1 upon a power 5, and here we can write integration of 1 by 4 is theta here plus 1 upon 8 theta plus 1 upon 8 into integration of cos is sin 4 theta upon 4 plus 1 upon 2 integration of cos 2 theta is sin 2 theta and divided by 2 plus some constant c, or applying the limits here pi by 4 to pi by 2. Sorry, here this is theta by 4, so we can write 1 upon a power 5 into, this is theta by 4 not theta, plus theta upon 8 plus 1 upon 32 times sin 4 theta plus 1 upon 4 times of sin 2 theta over the limits pi by 4 to pi by 2. So here we can write 1 upon taken common 4. So here 1 by theta plus theta upon 2 plus 1 upon 8 sin 4 theta plus sin 2 theta over the limits pi by 4 to pi by 2. So which is 1 upon 4 a to the power 5 theta plus theta by 2 is 3 theta by 2 plus 1 upon 8 sin 4 theta plus sin 2 theta over the limits pi by 4 to pi by 2, which is equal to 1 upon 4 a power 5 upper limits 3 by 2 into pi by 2 minus 3 by 2 into pi by 4, and again plus 1 by 8 into sine 4 into pi by 2 minus sine 4 into pi by 4, and again plus sine 2 into pi by 2 minus sine 2 into pi by 4. So here we can write 1 upon 4 a power 5 3 pi by 8 3 pi by 4 minus 3 pi by 8 and plus 1 upon 8 times. So here sine 2 pi is 0 and again sine pi is also 0. So 1 upon 8 times 0 plus here again sine pi value is 0 minus sine pi by 2 value is 1. So 1 upon 4 a power 5, here LCM is 8, so 6 minus, that is 3 pi divided by 8 minus 1, or we can write 1 upon 32 a power 5 3 pi minus 8. So 3 pi minus 8 upon 32 a power 5, which is option A. So we can go with an answer A. Integral 1 upon x plus 1 into root of x square minus 1 dx. So here let us substitute or put 1 upon x plus 1 is equal to t. So we can write x plus 1 is equal to 1 upon t. So on differentiating we'll get dx is equal to minus 1 by t square dt. And also x is equal to 1 upon t minus 1. So x square is equal to 1 by t square plus 1 minus 2 upon t, so that we can write x square minus 1 is equal to 1 upon t square minus 2 upon t, or we can take LCM t square 1 minus 2t. So let us substitute here. Integral dx is minus 1 upon t square dt. So we can write here minus 1 by t square dt upon x plus 1 is 1 upon t into under root of x square minus 1, that is 1 minus 2t upon t square. So we can write integral minus 1 upon t square dt divided by 1 upon t into 1 upon t under root of 1 minus 2t. So here we can cancel and we can write my integral minus dt upon root of 1 minus 2t. On simplifying we can write minus integral 1 minus 2t whole to the power minus 1 by 2 dt, which is equal to integral minus, let us use integration 1 minus 2t whole to the power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 into coefficient of t is minus 2. So we should divide with minus 2. So we can write minus of 1 minus 2t whole to the power 1 by 2 divided by 1 minus half is half into again minus of minus plus half. So half and half gets cancelled. So we can write root of 1 minus 2t plus c constant. So let us simplify, which is equal to under root of 1 minus 2 times of t is nothing but 1 upon x plus 1 plus c. So we can write under root of x plus 1 minus 2 upon x plus 1 plus c. That is under root of x minus 1 upon x plus 1 plus c. So which is option C. Option C is the answer. We need to find the value of integral 0 to pi by 2, or let us consider I is equal to 0 to pi by 2. Pi of x upon pi of x plus pi of pi by 2 minus x dx. So basically we'll use the formula, that is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So consider this is 1. So this integral we can also write I is equal to integral 0 to pi by 2 by using the property pi of pi by 2 minus x upon pi of pi by 2 minus x plus pi of pi by 2 minus x will become pi of x dx. Say this is 2. Adding 1 and 2. So we'll get 2I is equal to integral 0 to pi by 2 pi of x plus pi of pi by 2 minus x upon pi of x plus pi of pi by 2 minus x whole dx. So we can cancel both numerator and denominator, and we have I is 2I is equal to integral 0 to pi by 2 1 dx, that is 2I is equal to integration of 1 dx is x over the limit 0 to pi by 2, that is I is equal to pi by 2 into 1 by 2, which is pi by 4. So we can go with an option A pi by 4. Integral 1 upon sin square x cos square x dx. So basically we do by substituting 1 as sin square x plus cos square x upon sin square x into cos square x, so that we can simplify and we can get the solution. So which is equal to integral sin square x upon sin square x into cos square x dx plus integral cos square x upon sin square x into cos square x dx. So we can cancel here sin square 1 upon cos square is secant square x dx plus integral, here we can cancel cos square x 1 upon sin square is cosecant square x dx. Integration of secant square x is tan x and integration of cosecant square is minus cot x plus c. So we can give that tan x minus cot x plus c is the answer. So we can go with an option A. Option A is the answer. Integral 1 to 2 root x upon root of 3 minus x plus root x. So let us consider I is equal to integral 1 to 2 root x upon root of 3 minus x plus root x. Let us use the property integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So we can write here integral I is equal to 1 to 2 under root of 1 plus 2 minus x upon root of 3 minus of 1 plus 2 minus x plus root of 1 plus 2 minus x dx, which is equal to integral 1 to 2 under root of 3 minus x upon, so here we can write root x plus root of 3 minus x dx. Say this is 1 and this is 2. So adding 1 and 2, so we will get 2I is equal to same limits 1 to 2. So we can write root x plus root of 3 minus x divided by root x plus root of 3 minus x whole dx. So we can cancel this both and we can write 2I is equal to integration of 1 to 2 1 dx, that is 2I is equal to integration of 1 is x over the limits 1 to 2. So which implies 2I is equal to 2 minus 1. So I is equal to 1 upon 2. So we can go with an option half. Integral solution is 1 by 2, which is option C.